Hello friends, today we're going to talk about word problems involving right triangle trig. Our learning target, I can solve word problems involving angles of elevation and depression. Our state standard, apply the trigonometric ratios sine, cosine, and tangent to solve problems. Know how to use calculators, tables, or other technology to evaluate trigonometric ratios. So all of these problems are going to either have the words angle of depression or angle of elevation. Angle of a depression is when you have a horizontal line and you're looking down. So here's my angle of depression. Angle of elevation is from a horizontal line and looking up. So here's our angle of elevation. If we connect these here and make triangles, we're actually making two of the exact same triangles. One is just reflected. So the angle of depression is like an upside down triangle from the angle of elevation. This is the triangle we're going to be using if it says angle of depression. And this is the triangle we're going to be using if it says angle of elevation. Our angle of depression is always right there, and our angle of elevation is always right there. So let's look at some problems. Here also are some keywords that might help you. If they're asking for the vertical height, it's usually the opposite side. So if they're asking for the height of a cliff, a building, a tree, if they're asking for the horizontal distance, it's usually the adjacent side. So if you ask like how far on the ground or a shadow, distance from the base of something. If they're asking for the diagonal distance, so if you see line of sight, ladder length, kite string, they're asking for the hypotenuse. This is in most cases. So at a point on the ground 40 feet from the foot of a tree, the angle of elevation of the top of the tree is 42 degrees. So we're going to put that in here. And it said on the ground is 40 feet. And they want to know the height of the tree. So we have our reference angle, hypotenuse, opposite, and adjacent. We're using opposite and adjacent here, so we're using tangent. Tangent of 42 is x over 40, opposite over adjacent. Solving this one, we'll multiply both sides by 40. So the height of the tree then is 40 times tangent of 42. Here they're saying round to the nearest tenth. So the height of our tree then, rounded to the nearest tenth, would be 36.0 feet. Make sure on all of these word problems that you're labeling. Pay attention to what the label is. Pay attention to what they're asking you to round to. Find to the nearest degree, so that means I know I'm looking for an angle measure. The angle of elevation of the sun when a vertical means up and down, post 15 feet high, cast a shadow. Shadow is horizontal, 20 feet long. So we're looking for the angle of elevation here. Again, we have our hypotenuse, our opposite, and our adjacent. Again, we're going to be using tangent because we're given the opposite side and the adjacent side. So tangent of that angle is 15 over 20. And then remember to solve these, we just take the inverse of both sides. So inverse tangent of tangent x equals inverse tangent of 15/20. On the left here, the inverse tangent and tangent get canceled, so we're left with x. And on the right side, if we did the inverse tangent of 15/20 and round to the nearest whole number, we would get 37 degrees. Recall how you label an angle is degrees. Do not say 37 feet. That is a length. We're not looking for a length. We're looking for an angle measure, which means our label is degrees. An observer in a balloon, which is 2,000 feet above an airport. So 2,000 feet high. Find the angle of depression of a ship. So we're looking for the angle, finds the angle of depression is 21 degrees. Find to the nearest foot the distance between the observer and the ship. So we're looking for the hypotenuse here. We have our hypotenuse, our opposite, and our adjacent. We're given our opposite and we're looking for our hypotenuse, so we're going to be using sine. Sine of 21 is 2,000 over x. Remember, when x is on the bottom, it's a two-step process to solve for it. So first we'll multiply both sides by x, which gets our x out of the bottom. And then we have x times sine of 21 is 2,000. And now to get x by itself, we'll divide both sides by sine 21. On the left side here, the signs cancel. So then x is 2,000 divided by sine 21. Here they're asking us to round to the nearest foot, so we're going to round to the nearest whole number. And that would be 5,581 feet. From the top of a lighthouse 160 feet high, so that's how tall it is. The angle of depression to a boat out at sea is 24 degrees. Remember, we're always going to put our angle of depression there. Find to the nearest foot the distance from the boat to the lighthouse. It says the foot of the lighthouse is at sea level, so that's like the base of the lighthouse. So we're looking for this part. We have our hypotenuse, our adjacent, and our opposite. We're given the opposite, we're looking for the adjacent, so we'll be using tangent. Tangent of 24 is 160 over x. Here's another one where x is on the bottom, so it'll take us two steps. First, we'll multiply by x. X times tangent of 24 equals 160, because these x's will cancel. And then dividing by tangent of 24 on both sides. Again, here they want us to round to the nearest whole number. It says the nearest foot. So rounding to the nearest foot here, we would get 359 feet. So the distance from the boat to the foot of the lighthouse is 359 feet. An airplane which have taken off from an airport traveled the ground distance of 3,660 feet. What is the angle of elevation? That's what we're looking for here. From the point of takeoff to the point when the plane has traveled 4,150 feet through the air. And it says we're rounding to the nearest degree. So the plane is 4,150 feet high. Our hypotenuse, our opposite, and our adjacent. Again, we're dealing with opposite and adjacent, so tangent of x is 4,150 divided by 3,660. Again, to get x by itself here now, we need to do inverse tangent on both sides. So inverse tangent of tangent x equals inverse tangent of 4,150 over 3,660. On our left side here, the tangents cancel. So then we just have x equals, and if you do inverse tangent of 4,150 over 3,660 and round to the nearest degree, again, we're looking for an angle here. So it'd be 49 degrees. Do not forget the degrees. Do not say it is feet. It is an angle measure, so our label is degrees. Let's do a couple more. A surveyor is monitoring a drone hovering directly above a landmark. The surveyor is standing a horizontal distance of 25 yards from the landmark. The drone is hovering at an altitude of 165 feet. Find the angle of elevation from the surveyor's position to the drone. Round your answer to the nearest tenth of a degree. It says, hint, you must get everything in feet first. Right now, our vertical distance is in feet and our horizontal distance is in yards. So to go from yards to feet, we multiply by 3. 25 yards times 3 would be 75 feet. So we're not using the 25 yards for that side. We'll be using 75 feet. We have our hypotenuse, our opposite, and our adjacent. We're dealing with opposite and adjacent, so we're going to be using tangent. Tangent of x equals 165 over 75. To solve this, we'll do inverse tangent on both sides. Remember, the whole goal is to get x by itself, so in order to get rid of this tangent, we have to do inverse tangent, and we have to do it on both sides. On our left side here, the tangents cancel. So x then is inverse tangent of 165 over 75. Again, they're asking us to round to the nearest tenth of a degree, so it would be 65.6 degrees. Let's look at one more. This one's a little bit more difficult. It involves multiple steps. This would be a level 4 problem. An observer is standing on the ground level, 120 feet away from a launch pad. So that's where this 120 is coming from. A 2-stage model rocket is launched vertically. The first stage, the rocket ascends to its first burnout point. The observer measures the angle of elevation of the rocket to be at 35 degrees. Stage 2, the second engine ignites and carries the rocket higher. The observer now measures the angle of elevation to be 58 degrees. How far did the rocket travel during the second stage? So if you look at our picture here, they want us to find x. X is not part of a right triangle, so I can't just do it in one step and find x. What I need to do is look at my smaller triangle first. So that's what I have right here. And then secondly, we need to look at the whole entire triangle. That's what I have over here. Notice that I called the vertical height there z. And then to find x, we'll do z take away y. So let's look at our smaller triangle first and find y. We have our hypotenuse, our opposite, and our adjacent. We're going to be using tangent. Tangent of 35 equals opposite over adjacent, or y over 120. We'll multiply both sides by 120 here. It cancels on the left side. So y is 120 times tangent of 35, which means y is 84 feet. Again, we're rounding to the nearest foot. Now I'm going to do the same on this second one. Tangent of 35, not 35. I didn't mean to write 35 there. That one is 58 degrees. So tangent of 58 is z over 120. Solving this one, again, we'll multiply both sides by 120. So z is 120 times tangent of 58, which means that the length, this whole length of the big triangle is 192 feet. So if we look back here, The whole thing is 192 feet. The little part here is 84 feet, which means to find x, we'll do 192, take away 84, which is 108 feet. Again, that's a level 4 problem because it involved multiple different steps. All right, friends, that's all I have for you. Have a nice day.